All right, we talked a lot about polynomials yesterday. To tell you the truth, a lot of that stuff that we did yesterday, I mean, we'll use some of that vocabulary, we'll use some of those words. But what we're doing today is really the stuff I really want you to know, okay? I want you to know how to actually do some problems. And this is what we're going to do. So, example 4 is the first example for today. And this whole thing says, you know what I should do? I should throw in multiplying as well. So we're also going to multiply today. Hopefully, if we get to it. Right? First thing we're going to do is we're going to add. Okay? We're going to add the polynomials together. This is stuff you've probably done since Algebra 1, but we're going to go through it again because this is a review chapter, so this isn't anything brand new. It should just be review for you, I hope. If it's not, you can learn it for the first time. And it'd be a good idea if you took some notes out and you wrote some of this down. Plus 6x minus 2 plus 3x to the fourth. This looks like a big, long problem. It's not as bad as it looks at first glance. Plus x squared plus x. All right, here we go. So we're going to add polynomials. We talked about this yesterday of what kind of things you can add together. Do you remember the phrase, you can only add what? Blank, blank. Like terms. Like terms. So what we want to do is we want to find out which ones are like terms. Okay? So where do you start? Start with the first one. Okay, how do I know which term it is? Does it matter what the number out in front is, the coefficient? No, it doesn't matter the coefficient. It's all the other stuff. It's the variable and the exponents. They have to be exactly the same. The coefficient can be different. Coefficient just tells you how many of those things that you have. Everybody hear me? Okay? It's the term itself. So this term right here is an x cubed term. So I go through the list and I see if I have any other x cubes. Do I have anything else with x cubed? Well, that's not. Well, there's another one. There's one right there. So I've got this one and this one. So I can add those together. So I'm going to just put them together. Doesn't matter what order you add things, does it? All right, so I'm going to put them together. So I'm going to go 8x. Now, you might be able to do this in your head. Okay, you might be able to do it right now in your head, but after a while doing these, you definitely should just be able to look at these and just say, oh yeah, that's 8x cubed minus 2x cubed is blank, and then write it down, okay? I'm going as basic as I possibly can. Everybody got me on that? So what I'm doing right now, you don't necessarily have to do, because you could answer this whole question, just do it in your head, write the answer down, all right? And that would be fine. Even though I harp about showing your work all the time, there's really not a lot of work to show. But I'm going to show you as much work as I possibly could. So 8x cubed minus 2x cubed, so 8x cubed minus 2x cubed. A lot of times I like to do is this. Since I've already written them down, I like to mark them off, so I know I'm done with it. You don't have to do that, but sometimes that's nice. All right, let's find another one. I got x cubed. Actually, let's do this. Let's put it in descending order. All right, what's the highest order? What's the highest exponent? It's 4. So that would go first. Are there any other x to the fourths here, though? There's not. So I can't really add those together. So I'm just going to put that up front. It's not just a 3. It's a what? It's a positive 3 x to the fourth. So it's a, whoops, let's go back to white. So it's a 3x to the fourth plus all these. All I'm doing is just grouping all the like terms together. All right, I'm done with that one. So I got x to the fourth first. I get my x cubes. What's the next power? What's the next order? The 2's, right? The squares. Yes? Okay. So let's, I'm going to mark those. I'll put 2 under that. All right, so I got x squared here. Where else do I have an x squared? Right here. All right, so let's add those together. So I'm going to write them down. And what do I have here? It's not just a 2. What do I put in front of it? A negative 2. It's very, very important. That's where a lot of students go wrong, is forgetting to put the sign in front of it. So you got to put the minus 2. What's the other one? It's plus what? 1 x squared, not x2, x squared. All right, I'm done with those, so I can mark those off. Let's keep going in order. There's an x squared. What's my next one? It's just the x, right? So I've got a 6x and I got a 1x. Let's write those down. Plus 6x plus 1x. I'm done with that. And then what else do I have left over? Just that minus 2. So the number just goes at the end. Again, you could have done a lot of this stuff in your head. But I'm going to do it this way because I want to add all the like terms. Now, 3x to the 4th. Are there any other x to the 4th I can add with that? No, so I just write it down. 3x to the 4th. I'm done with that. Let's add these two together. All right? When I say add, sometimes it might be a subtract, right? Because of the minus in front of it, technically it's subtraction. So it's 8x cubed minus 2x cubed. So what's 8 minus 2? 6. And it's positive, so we put a plus 6, what? X cubed. Do I do anything? Do I add those cubes? No, they're just like terms. It's like apples and oranges. Remember that? If I have 8 apples minus 2 apples, I have what? 6 apples, right? I got 8x cubes minus 2x cubes. That gives me 6x cubed. All right, done with those. Now, let's do these right here. I got negative 2x squared plus 1x squared, which is minus 1x squared. Do I need the 1, though? I could just write negative x squared or minus x squared. I'm done with those. What about these? Positive 6x plus 1x is plus 7x. I'm done with those. And then I just got a minus 2. And that's it. Okay? Everybody should have this written down on your notes. See some people not writing? That's your problem. It's not my problem anymore. I've told you, you know what to do. And if you're not going to do what I ask you to do, and you don't get these right, I don't know what else I can say. You know, I've done my job. You got to do your job. All right, let's do another one. Example 5. This time we're going to subtract polynomials. Now, we kind of did some subtraction on the other one, didn't we? We did one subtraction, right? 8x cubed minus 2x cubed. So technically we did a subtraction. And what? Negative 2x squared plus 1x squared. Maybe you could think of that as subtraction as well, I guess. But this is going to be a little bit different. So here it is. Everybody watching? Oops. Let's try that again. 3x to the 4th minus 4x cubed plus 6x squared minus 1. They put that in parentheses, and they put a minus, then they put another parentheses. This is the key to that problem, that parentheses and that minus. That's why they call it subtraction. 8x squared minus 6x plus 5. All right? So, here we go. Now, they put parentheses around that first one, but to tell you the truth, you don't really even need that parentheses. Is there anything being multiplied by the stuff inside of here? No. All right? So, really, there's no need for this parentheses. So, if you want to get rid of it, you can. But on the next one, there definitely is a need for the parentheses. Why? Because of that negative. That's right. Now, if it was a plus, it wouldn't make any difference because all you're doing is keeping the signs the same. But what is that negative doing? It's flipping the signs of everything. It's changing the signs of everything in here, okay? So technically, here's a word that we haven't, have we talked about this? Probably not. Now, when I do this, do you remember this? We're going to talk about that in a little bit. What is that?
FOIL.
It's not FOIL. It's distributive property. Very good, okay? So you got to take that negative and you have to distribute it through everything, which means make everything negative. Now, guys listening? Because you're going to miss something here. When I say make everything negative, you're not making this negative. It's already negative. So what does the negative do to that negative? Makes it positive. What this does is changes the sign of everything inside of there. So this was a positive 2x to the fourth. What's it going to be now? Negative. What's this going to be? Plus. What's that going to be? Plus. What's that going to be? Minus. Everybody see that? You got to make sure that you understand that. A lot of students, I just gave a quiz in, I don't know, one of my classes, Algebra 2 or Geometry, where you had to distribute a negative, and they just distributed it through the first one and not the other ones. All right? You got to distribute through everything that's in the parentheses. That's why that parentheses is really important. The parentheses we had out here really didn't do anything, so we could have gotten rid of it, and I did. So let's write everything down. So we didn't change anything to this first set of numbers. So I'm just going to rewrite everything. Now, I got to change the sign of everything in here. So what's it going to be now? It's going to be minus 2x to the fourth. This is going to be plus 8x squared. This is going to be plus 6x. This is going to be minus 5. Everybody with me? That's the only thing different about this example. After we do that, the rest is just like what we did before. So let's go through it. What's the highest order here? What's the highest power? To the fourth. So let's combine those together. Again, since we're just learning this, I'm going to write them out. You might be able to just look at it and go 3x to the fourth minus 2x to the fourth is 1x to the fourth. And if you do that, that's fine. I got no problem with that at all. But I'm going to write them all down, okay, since we're first teaching this. 3x to the fourth minus 2x to the fourth. Let's write it down. And if this helps you, by all means, go ahead and do that. Okay, write them down. Group all the like terms together. Right? Sometimes it gets too confusing with all that stuff there. So if it helps you, go ahead and group them together like I'm doing. All right, I'm done with that, done with that. Yes? No. Let's do the next part. X cubed. And that's the only x cubed, isn't it? There's no other x cubes here. So I'm just going to write minus 4x cubed. And I'm done with that one. The next one down from that is x squared. I got an x squared here and an x squared here. That's it, so I write them down. That's a plus 6x squared and a plus 8x squared. I'm done with that. What else? I only have one with just an x, don't I? So I put plus 6x. I'm done with that. Then I got a couple regular numbers. I got a negative 1 minus 5. So negative 1 minus 5. And I'm done with those. So I've written everything down. But you see what I did? I grouped them all together by like terms. I don't know. Does that make it easier or not? Maybe. Yeah, maybe on something as long as this, maybe you want to do that, all right? Because it might be confusing if you don't. But if you can do those in your head, if you can just go 3x to the minus fourth minus 2x to the fourth is 1x to the fourth, that's fine. I don't care. So let's do it. So I've already said this twice already. 3x to the fourth minus 2x to the fourth is 1, what? X to the fourth. We don't have to have the 1 there, but if you put the 1 there, it's fine. No big deal. You just don't need it. So I'm done with those. Now, I only have 1x cubed, so I can't add that to anything else, so I just write it down. Minus 4x cubed. I'm done with that. Then, right there, those are like terms, so I add those up. Plus 6 plus 8 is plus 14, what? X squared. Don't add those squareds together. Everybody got it? Again, that's a common mistake students make. And then what else we got? The 6x, there's no other just regular x's, so I just write plus 6x, and I'm done with that. I got negative 1 minus 5. How do you do that? Add the opposite. Remember that? Add a line, change sign. Yes? All right, so what's negative 1 plus negative 5? Negative 6. And there you go. You can't do anything else. All right, because I've added up all my like terms. None of that other stuff will add together, so I just leave it like that. Looks like a difficult equation. There's a lot of stuff here, a lot of squares and x's and all that kind of stuff. It's really not that hard. Just distribute the negative through here and then add up your like terms. No biggie. How do you feel about that? Good? Yeah, I think it is. But you got to be careful. There's a lot of room for mistakes, isn't there? There's a lot of room to make mistakes. The signs especially, all right? Make sure you put the negative when there's a negative, put a positive when there's a plus, all right? Make sure that you do that. All right. What do we say we're going to do now? We did addition, subtraction, and I threw in what? Multiply. Yep. Now, there's going to be more multiplying in the next lesson. We're going to do a little bit more complicated multiplying. Right now, we're going to do some basic multiplying. Okay? So let's write that down. So now we're going to multiply polynomials. We've already multiplied some things together before. Remember, we did some real basic stuff. Remember, we learned the rules for multiplication? If I had like x to the third times x to the fifth. Remember the rule for that? Yeah, we keep the base the same, and what do you do with the exponents? You add them up. 3 plus 5 is 8. So technically we have multiplied polynomials, because this is a monomial, that's a monomial. So yeah, technically we have. We're just going to get a little bit more involved. So let's take that just a step further. What if I go 2x cubed times, oh, I'm sorry. I put to the fifth here, didn't I? Oh yeah, that's right. That's fine. That's fine. Yeah, I'm good. Sorry, I was thinking of something else. 5x to the fourth, let's say. All right, so I changed that x from a fifth to a fourth, okay? Now, what are we going to do here?
Multiply the
coefficients, good. Multiply the coefficients, and then go ahead and multiply the variables, okay? So I just take the regular numbers, if you want to call them that, the coefficients, I multiply those together, 2 times 5. Let's write it down. 2 times 5, okay? Again, I'm getting super basic on you, but you don't have to write that down. You could do the 2 times 5 in your head, all right? But I'm getting really basic. And then we got what? X cubed times, what is it this time? X to the fourth, okay? Let's keep going. 2 times 5 is 10. And then this is going to be x to the what? 7th. And there you go. Again, you should be able to go directly from this to this without really showing any steps. I just showed you what you're kind of doing in your head. Everybody good? All right. Let's take that a step further. Seems like that's what math's all about, isn't it? You learn one thing, you think you got that down, and then the next day you come in and then there's something that builds on top of it, right? That's what it is. That's what math is. So let's do this one. We got 3x times 2x squared plus 5. Now, we mentioned this word a few minutes ago. What's that word we mentioned that we're going to use right here? Distributive property. That's right, because that 3x, it's not just being multiplied by the 2x squared. It's multiplied by everything in the parentheses. So we do a thing called distribute. We multiply this thing by both terms. We multiply it by the 2x squared, and then we multiply it by the 5. Again, I've said this like 3 or 4 times today. I'm going to say it again. You could do this just in your head right away. All right, and that's fine. Again, I want you to get to that point where you could do that. But I'm gonna write it down so you see what you're doing in your head. So what are you doing? You're going 3x times what? 2x squared. And then, here's that sign right there. You're going to put a plus, and then you're going to go what? 3x times 5. Now we can do a little bit in our head. Let's do this part in our head right here. So I got 3x times 2x. So I go 3 times 2 is 6. X to the first, right? X is just x to the first. Times x squared is what? X to the third. Don't say x3. Okay, that doesn't mean anything. All right, x to the third. Or you could say x cubed. All right? Plus, what do we do here? 3 times 5, 15, and then an x. Then you're done. Can you add those two together?
No.
Why not?
They're not like
They're not like terms. That has an x cubed. That's just an x. Can't add them together. That's your answer. You leave it like that. Listen, most people, not most, I could say it that way. Most people that mess this up probably mess it up because they don't distribute through the second one. I've seen it so many times. You're watching, right? I've seen it so many times where that first one, they multiply, but then they forget to multiply it by the second one. So you got to make sure that you do that. All right, let's do another distributive property. This one's a little bit, I'll tell you what, I'm going to do one that I don't have in my notes before we get to the next one. I'll just make one up. Somebody said a word earlier that did not fit then, but it does fit on this. FOIL, okay? Now, I'm not really going to teach you the FOIL right now, okay? What I want to show you is that this is distributive property. Very, very similar to this. But what do we got outside that parentheses? What kind of a polynomial do we have? The name of it. What kind of, there's a name. We have 3 polynomials. It's a monomial. This is a monomial. So we have a monomial times a binomial. That's right. We had a monomial times a binomial. This time we have a binomial times another binomial. Okay? That's when you would use the FOIL method. You've learned the FOIL method in probably several different classes you've had prior to this. Danae's giving me that look like, nope, never heard of it in my life. But we're going to learn it. We're going to learn it tomorrow, okay? But I'm going to show you how to multiply this together. This is still distributive property. A lot of people think, well, FOIL methods, the FOIL method is really only used in this situation when you have 2 binomials that are being multiplied times each other. Teachers just came up with this FOIL method just to make it a little bit easier for you to understand. But to tell you the truth, you don't even have to know anything about FOIL to be able to do this, because you could just think of distributive property. So look, you got 2 things in here, but each of these are being multiplied by each of these. You with me? So this x is being multiplied by the first one, and it's what? It's being multiplied by the second one. Yes? But the second one in the first binomial is also being multiplied by the first one here and the second one over here. It's just distributive property, right? We take the x, multiply it by both of these, then we take the 3 and multiply it by both of these. So really, this is just distributive property, isn't it? Yep, technically it is FOIL. We'll talk about that tomorrow. But let's do it. Let's go this x times the first one, so that's x times x. We can do this in our head. What's x times x? X squared. Then you take the x and you multiply it by the second one. So it's x times negative 2. How do I write x times negative 2? That's it, negative 2x. All right, if I multiply x times negative 2, it's the same thing as multiplying by negative 2 by x, isn't it? Same exact thing. I always like the number to go out in front, right? That's a coefficient. I don't want to write x and then dot negative 2 or x parentheses negative 2. This looks a lot better. All right, I took that x and I multiplied by everything. Now what do I got to do? Take the 3 and multiply it by everything. So let's do that. It's a positive 3 times x, which is a plus 3x. And then it's a positive 3 times a negative 2. Make sure you use those signs. What's positive 3 times negative 2? It's a negative 6. Are we done? Do we circle it? No, because we have to still do what?
Like terms.
We got to add like terms. You always have to simplify your answers. Okay? If you left it like this, I would mark it wrong, and I would probably write next to it, simplify. And if I'm really in a bad mood, I might put an exclamation point. Okay? Oh, beware of the exclamation points. All right, anyway. So let's add like terms. There's no x squared, so I just write down x squared. What do I do here? What's negative 2x plus 3x? What's negative 2 plus 3? It's a positive 1, isn't it? So this is a what? Positive, so you put a plus. Lana, I'm up here. Plus 1 what? X. You can put the 1 in front of it if you want to. There's no need to. And then minus 6. And that is your answer. Eventually, I'm not sure when, my guess is pretty soon. Everybody watching? Got a lot of, I'm seeing tops of heads. I shouldn't see tops of heads. I should see eyeballs. Are they real glasses or these sunglasses? Is it that bright in here? Got all the lights out. All right, anyway, look here. Eventually, we're going to be doing this. They're going to give you this, and they want you to come up with that. Remember doing that? Probably did that in Algebra 2, didn't you? It's called factoring. Do you remember doing factoring? No? Getting a lot of blank scares. You don't remember that word, factoring? You took a whole Algebra 2 class and you never did factoring? Wow. All right.
Wait, why did you guys never do that?
You guys did it?
Yeah.
You did. Oh, there was two different CP classes? Algebra 2 classes? Oh, okay. Well, anyway. That's something. We're going to do quite a bit of it this year. All right, so don't ever leave here and a teacher say, have you done factoring? And you give that look. Huh? What? Factoring? No, we're going to be doing it. We're going to be doing a lot of that. All right. Let's do one more, and then we'll quit. You ready?
Then we'll quit.
That's what I said.
I don't like quitting.
All right, then we'll keep on going until the bell rings. How about that? All right, so now, what did we just multiply before? Well, the first one we multiplied was a monomial times a binomial. Then we multiplied two binomials together. Now we're multiplying what? A binomial times a trinomial. Is it? Is it getting somewhere? It's just one little tiny step past what we just did. It's the same exact thing, except this is being multiplied not by two different things, but by three different things. So we don't really use FOIL, but it's still distributive property. So we take this and we multiply it by all these three. Then we take this one and you multiply it by the same three. You don't have to draw these little lines there. We just do it to visualize what you're multiplying. And I think at first, I think it helps. Okay? So let's take that 2x and multiply it by everything in here. So 2x times x squared. That's 2. X times x squared. It's not x3. Thank you. It's x to the third. You could say x cubed if you don't like to the.
It's just a bad habit.
All right? It's not x3. x3 would mean this. x3, to me, that would mean x times 3. This is not x times 3. It's x to the third power. I know what you're saying. I know I get it. I get it. I'm just being super picky, but I think it's important to be picky here. All right. So we took the 2x times the first one. Then we take the 2x times this one. We got a positive times a negative, so that's going to give us a negative. It's 2 times x, which is 2 what? X squared. Good. And then we got one more to do with the 2x. 2x times the last one. They're both positive, so it's a plus. 2x times 2. 2 times 2 is 4x. All right, we're not done. We still got to take that 5, and you got to multiply that 5 by all three of those numbers. So let's do it. Plus 5x squared. Easy enough. 5x squared, right. And then plus 5 times negative x. Well, it's a positive times a negative, which is negative, and 5x. And then it's positive 5 times positive 2. Let's do that in our head. Positive 10. Are we finished? Do we circle it? Are we done? No. You always look for what? Like terms. Okay, let's start with the highest one first. We're putting it in what kind of order? Descending order. So always go with the first or the highest order first, okay? That's why we learn how to do the order of the polynomials, okay? So what's the highest one first? X cubed. Are there any other x cubes I can add that with? No, so I just write down 2x cubed. I'm done with that, so I like to mark it off. You don't have to, but I like to. Let's do the x squareds. I got a negative 2x squared, a positive 5x squared. What is negative 2 plus 5? Positive 3. All right, so this is going to be plus 3x squared. I'm done with the x squareds. Now I got some x's, don't I? I got a couple x's. I got positive 4x minus 5x. What's 4 minus 5? It's negative 1. So this is a what? Negative 1x. Do you need the 1 there? You don't need to. All right, if you want it there, it's fine, I guess. But you don't need it. Looks a little nicer without it. All right, I'm done with the x's. What else do I have? Plus 10, and that's it. I'm done. That's my answer. There's no other like terms I can add. It's in descending order. It should be good. All right? Check mark. You got it right. Make sense? Good. All right, we're going to be doing more multiplication tomorrow. A little bit, not much. A little bit more complicated. We'll basically be doing FOIL method tomorrow, all right? We kind of did it already today, but we're going to look at why we use the word FOIL and all that good stuff. So, now, you do have an official homework. Yesterday I gave it to you, but I said you didn't have to do all of them. So we'll call this R4A since it's our first homework on R4. And it's page 48 and 27 to 45. And that's your homework right there.
All of them are just come here, picture.
And odds.
Just write it down.
Since Tristan said odds, we'll put it as odds. Why don't you just write it down?
Because I'm going to look at the video.
It's fine. It's going to be on YouTube. I said it's fine. Go ahead. Do it. Take a picture of it.
Appreciate it.
Sure. Any other questions on this stuff? Everybody good?